We have our unit circle right here, and then we're going to move on down. Yep. Okay. I'll pause and let you do a 5-second high in a few minutes. Okay, so here we just did this one. We used the fact that we had S equals R theta. We were looking for theta, which was then S over R. You guys told me that was 42 feet over 7 feet, which gave you 6. Okay, for the next one, we're using the degrees to radians. Degrees is on top, which means in your conversion factor, degree has to be on bottom. So we have 180 in the denominator. We have pi on top. So that way we have things with the same units can cancel. Yes, sir? Are you recording right now? I am. Oh, my God. Okay, so when we do this, what goes into 135 and 180?
5.
So how many times does 5 go into them?
135. Into 135, I think 27.
So we end up with 27
over 36.
Which
reduces to 9 over 12.
Which reduces to 9 over 12.
Which reduces to 3 over 4 pi.
3 over 4, and I dropped a pi during it, but so we just keep that with it. And so we have 3 over 4 pi radians, yes. And then our next group, we have negative 300. So negative 300, what we're going to do here. Okay, so for here, we're doing the same thing. You have pi over 180. What goes into both of these? 60 goes into the top. How much?
5.
Negative 5 pi over. Yep, that's it. And then the last one, similar style, pi over 180. What goes into 115 and 180?
5.
So what are you left with?
3 pi over 36.
Nice job.
You
Okay. We have pi over 3. So we have pi over 3. We're multiplying it by that same conversion rate because 180 degrees equals pi. We put pi in the bottom, 180 degrees here.
I know it.
So we see here, what'd you get?
60 degrees.
Nice job, 60 degrees.
Just my circle.
That works as well. You could have used your circle, but in case you didn't remember.
What?
It's on the unit.
Okay, so here we're canceling our pi's. 5 goes into 180 how many times? 36 times 12. What is it, Giselle? 432 is the correct answer. Nice job.
I can tell all y'all features right now.
How did you do that, Kennedy? You just told me you knew, so how'd you do it? So we're going to add 2 pi because we want it to be positive. So we're going to add 2 pi, which is the same thing as negative 3 pi over 6 plus 12 pi over 6. Because remember, you're getting a common denominator there. This gives you 9 pi over 6. You reduce because of 3. So we get 3 pi over what? 2. Nice job. Okay, here we want between 0 and 2 pi. That's 2 pi is 360. So I have to get 730 down to be underneath that. So what am I subtracting by? So I subtract 360. What am I left with? Is that still bigger than 360?
Yes,
So I got to subtract 360 again.
Subtract again.
10 degrees. So we're doing all 6 trig functions, so I'm going to set them up. I know you guys already did them. So sine of pi over 6. We have cosine pi over 6. We have tangent pi over 6. We have cosecant of pi over 6. Secant of,
Pi over 6.
thank you. And last but not least, I have to move it over here, cotan of pi over 6. Okay, so when you go to the unit circle and you find the value associated with pi over 6, what is it going to be?
30 degrees.
So it's going to be 30 degrees. And at 30 degrees, we end up with the square root of 3 over 2, comma, 1/2. So remember, chicken strips, CS, Caesar salad. So we go here and we see sine is the S1, so it's 1/2. Cosine is the C, so it's square root of 3 over 2. Tangent, tan, is sine over Cosine. That's you from yesterday. You need to remember that. Okay, so here we have this. So sine was 1. Oh, sadness. Zoom recording. So tisk sine over cosine. Sine was 1/2 over square root of 3 over 2. I moved it up. So I end up here with 1/2 times. Dividing by a fraction is the same thing as multiplying by a reciprocal.
2 over root 3.
Those would cancel.
1 over root 3.
So cosecant is the reciprocal of sine. So it's going to be 1 over 2 or just 2. Here, secant is the reciprocal of 1 over, nope. Secant is the reciprocal of cosine, which is going to be 1 over cosine. So we end up with 1 over square root of 3 over 2, which is going to be 2 over square root of 3. We rationalize. What do we get? 2 root 3 over 3.
Good job, Corbin.
2 root 3 over 3. And then we have our last one, which is what? Cotangent.
1 over root 3 over 3. Question mark?
Which is going to be what?
Is it going to be 1 over root 3 over 3?
Or we can go back to that just being root 3 here, and that would be, let me do it like this. I'll do it this way. It's going to be 1 over square root of 3 over 3, which is the same thing as 3 over square root of 3. We rationalize that square root of 3 over 3. You can't see it. We finished that work up in the top corner. Okay, so here, we see where this is at on our unit circle. Where would this be at? It's 270. Yep. We call this a quadrantal angle. What is our point there? Nice job. So let's go set these up. Sine of 3 pi over 2. Exactly right. Cosine of 3 pi over 2. Negative 1.
That's a 1?
That's a 1. Okay. So we go...
Oh, this the other side.
Okay, so here we see that we have sine. So we already talked about this, chicken strips. Sine is going to be negative 1. Cosine is going to be 0. Tangent is what? Sine over cosine. Sine is negative 1. Cosine is? So that goes to what? Nice work. Okay, over here we have cosecant of 3 pi over 2. We have secant of 3 pi over 2. And we have cotangent of 3 pi over 2. Okay, here we have the reciprocal. So that's 1 over negative 1, which gives me what? Negative 1. Here we have 1 over 0, which is undefined. And last but not least, we end up with 0 over negative 1, which is 0. Okay. Yes, sir. Here, and we are looking at the point negative pi over 3. So, when we have negative pi over 3, when we did this previously, what did we do? We found our reference angle, right? So we found that by doing what?
What is the difference between reference angle and a coterminal angle?
We see that we want to find that value. So that's negative pi over 3. And we're going to add 6 pi over 3. And we end up with 5 pi over 3. Which makes sense, because if you come up to your unit circle, the negative tells you that you're going down. You're going negative pi over 3 down. That brings me right here. So my reference angle, oh, I flipped it, I'm sorry. My coterminal angle with that would be adding that pi over 2 there. I even explained it to you and then I still flipped it, I apologize. Okay.
The reason you added 6 pi
I wanted,
because you skipped the step and added 2 pi?
I added 2 pi, yep.
All
So
right.
I get back to the same spot.
See, I'm getting it.
I'm happy to hear that. Yes, ma'am.
So if it's a negative and you're trying to find the, like all the trig functions, if it's negative, you want to add 2 pi to make it positive.
Just to get it positive, and then you use which one it is. All students take calculus and then treat it that way.
Okay.
Okay, so when we're here, we have sine of 5 pi over 3. I'm actually going to switch that back. I know, negative pi over 3. Sine in this quadrant, which is my last quadrant down there, which is it positive or negative?
Negative.
So what is my coordinate point that goes with 5 pi over 3? Okay.
What is that for these things?
Okay. Just root 3. You can put the negative with either half, the numerator, the denominator. Okay, sorry. What was you saying, Bryant? What were you saying, Bryant?
I said secant is one of the cosine, right?
Exactly right, the reciprocal functions.
So it's going to be 1. Basically, it's going to be 1 times 2, which is 2.
So it's going to be 1 over 2, which will just be 2. Okay, and then our one here is going to be cotangent, which is going to be 1 over... You want to tell me the answer there?
Yeah, okay, whatever.
Okay. Now you had to use a Pythagorean identity. We had 3 Pythagorean identities. I told you to put those on your page. The number one is sine squared plus cosine squared equals 1. We talked about how you could manipulate that one into the other 2. What is our other one that we use?
I forgot about it. I didn't know how to do this.
For the win, yep. So we're using 1 plus cotangent squared theta equals cosecant squared theta. Okay, in this situation, I am looking for the value of cotangent in our first quadrant. We know that cosecant is 1/2, so I can substitute that in. I have 1 plus cotangent squared of theta equals 1/2 squared. This gives me 1 plus cotangent squared theta equals 1/4. We've got to subtract 1 from both sides. I end up with cotangent squared theta equals 1/4 minus 1. I have cotangent squared theta equals 1/4 minus 4 over 4. If you want to skip that step, I'm okay with it. So we end up with cotangent squared theta equals negative 3 over 4. We want to square root both sides. I end up with cotangent of theta equaling the negative square root, square root of negative negative 3 over 2. We're here and we want to draw that picture of a 30, 60, 90 triangle. So take a second. If you didn't draw your triangle, put it on your page. So remember, these go 1, 2, 3, where 3 is the square root. It goes in order where your biggest angle goes with your biggest side. My biggest angle is 90 degrees, so the 2 goes with it. The next biggest angle is 60. The next biggest number is square root of 3. It goes with it. 30 is my smallest. My smallest side is 1. It goes with it. Okay, so here I'm looking for pi over 3. What is the equivalent to pi over 3?
60 degrees.
60 degrees. So I'm using this angle. So now I want to do those exact same trig functions. So sine 60 degrees, cosine 60 degrees, tangent 60 degrees. Okay. So sine is what? So it's opposite over hypotenuse, so square root of 3 over 2. Cosine is adjacent over hypotenuse, which is going to be 1 over 2. And tangent is what? Opposite over adjacent?
Yeah.
Square root of 3 over 1, or just square root of 3. Okay, now we have cosecant of 60 degrees, secant of 60 degrees, and we have cotan of 60 degrees. Okay, so these are just the reciprocals, or hypotenuse over opposite. So we end up with 2. You already see the flaw in me not leaving enough space. 2 over square root of 3. After we rationalize that, that becomes 2 square root of 3 over 3. With secant, it's the reciprocal of cosine, which just becomes 2. And cotangent becomes 1 over square root of 3. Once we rationalize, it becomes square root of 3 over 3. You're trying to build a bridge across a lake. Super exciting. And you want to calculate the distance. And you see your triangle here. I don't know if you can see the lake on your page. Mine's a little hard to see. So what trig function relates the two sides that we have? So you have tangent of 24 degrees equals, exactly right. We end up with 750 yards times tan of 24 degrees. When you're doing this, make sure your calculator is in degrees. We've been switching between degrees and radians. This requires your calculator to be in degrees. Now that you have that, what'd you get?
334.
334 yards.
That's it.
Yep.
This one is to draw it out because I'm a visual person. And so I see that I'm going 4, 7, put it right here. So I know 4 this way, 7 this way. The angle that's formed is right here. So now I'm interested in finding all the trig functions again, but now I need to find my hypotenuse. How do we find my hypotenuse?
R equals square root of x squared plus y squared.
Exactly right. So R equals, we end up with 4 squared plus 7 squared, which gives me the square root of 16 plus 49,
65.
which is the square root of 65.
It doesn't simplify.
Well, yep, won't break down.
It's weird.
Does it?
It's weird.
Okay. So I worked with mine in terms of square root of 65. Made me happy. I was okay with that. Okay, so I have sine of theta equals, I'm going to do cosine. I'm going to do it across this time of theta. And I have tangent of theta. So sine, opposite over hypotenuse. So that's going to be y over r, which is going to be 7 over square root of 65. When I do this, I end up with what?
7 root 65 over 65.
Exactly right. Nice job. Over here we do x over r, 4 over square root of 65. I end up with, okay, and then we're at tangent, which gives you what? 7 over 4. Okay, so for space, I'm going to move it up the side right here. I'm going to change my color. I can do cotangent below. Cotangent of theta is going to be x over y, which is going to be 4 over 7. Oh, up here we have sine. Nope. We have cosecant of theta, which is the reciprocal. I'm going to go back to this portion right here and reciprocal that, which is the square root of 65 over 7. We have secant of theta. Going to go back to this one. I get the square root of 65 over 4. So for 11, we're at pi. So on your unit circle, it's 180 degrees. My coordinate point's going to be?
-1, 0.
So if we have sine, I'm going to do sine of pi, cosine of pi, tan of pi. It's the same thing. We're just doing them for quadrantial and other angles. We have cosecant of pi, secant of pi, cotan of pi. So, chicken strips. 0, -1.
Undefined.
So this one is sine over cosine, so it's going to be 0 over -1, so it's going to be 0. Over here, we end up with 1 over 0, which is undefined. We have 1 over -1, which is going to be -1. And then here we end up with 1 over 0, which is going to be undefined. Our next one talks about finding the reference angle for secant of -pi over 3. So this is where we have that theta prime equals -pi over 3 plus, and we're going to add our 2 pi to find that. Remember, that deals with which angle or which quadrant you're in and what you add to it to get it back to that x-axis, over 3, which is going to be, yep, so we can do secant of our reference angle. Tells us that secant is going to be, actually I don't want to do it that way. It's going to be 1 over cosine of pi, 5 pi over 3. What's our value of cosine at 5 pi over 3? It's going to be 1/2, which gives us 2. Then you're going to look and see where this angle is at. And we see there that cosine is positive in that quadrant. So you're down here. Yep, all students take calculus. And so when you're down here, cosine's positive, which means that that is going to stay as a positive 2. And your last point on here. Nope, second to last. So we are going to estimate the height of a tower. So I'm just going to draw a triangle. You are 60 feet from the base of a cell phone tower. You have an angle of elevation of 76.4 degrees. And you want to see how tall this is. What trig function are we using?
Tangent.
We're using tangent because we have opposite and adjacent. So tangent of 76.4 equals opposite over adjacent. You end up with 60 times tangent of 76.4. Remember, this is supposed to be in degrees. What value did you get? 248. Okay. And this is in feet? Okay. We see that we are looking for the bearing for O to A. So from the origin to point A, which is right here. Remember, we do this by using the north-south line. So we're starting at the north line and we're moving this direction. How far over did we move?
70.
Yep, so you did 90 minus 20, which gave you that 70. So we end up with north.
We always start in